little talk about what is and is not working on ARM64. I gave more or less the same session at FOSDEM, which was surprisingly popular, but I'm hoping that you lot have slightly more expertise in what is and is not, in fact, working. So, just in case you don't know, I am Wookie, ARM porter, Debian developer for a long time, doing various things, mostly for the last few years, ARM64 bootstrapping. Been doing Linaro since it started, and I get paid by ARM. So the idea of this is to find out what is still broken. Most things basically work now. We've built it all, but I think there's probably quite a lot of things that's using the default implementation, or there could be optimizations, or there could be hardware-specific optimizations. There's a few things that are probably just missing. And it's very hard to know about all the software in the world. So we kind of got to the point where we should look at how we can direct effort from here on in things that still need work. So I'm keen to collect any suggestions people have. So please stick your hands up if you've got anything to say at any point during this exercise. Otherwise, I'll just talk at you. The bottom line is it mostly works. We've built nearly everything, pretty much everything that anyone cares about. Now, I'm a build engineer, so if it builds, it's done. So, in fact, it's done. That's it. Woo! However, it turns out that sometimes just because it built, it doesn't actually work, and maybe we should check some of this stuff. So, there's quite a lot of desktop apps, stuff like Blender and things. I'm not sure anybody's actually using that stuff on the hardware we've got available at the moment, so for all I know, it doesn't work. But actually, almost everything people have tried does in fact work. It's surprising how well just building things works in practice. So, yes, I think I just said all that really. So a little bit of history. This ARM64 porting effort started back in 2010. We had some binary toolchains out of ARM and started trying to build Ubuntu. And we didn't have any hardware. About some months in, we got access to the fast model, which is a misnomer if any of you have ever had to use it. It's extremely slow. It's slightly faster than the gate level simulator things, is what they mean by fast. It's appallingly slow. And then thanks to the SUSE people, in 2013 we got QEMU, which helped a lot, because the other things, the fast model couldn't do anything multi-threaded, and various things broke. Actually, QEMU couldn't do multi-threaded either, so still, if it needed Java, you still couldn't do native things. So there was an awful lot of cross-compiling, and we finally got some hardware in 2014, and our lives improved significantly. Thanks to Chen over there for providing me some early access to hardware, or Debian some early access, which was great. So it turns out if you need to bootstrap the thing, you actually end up doing it 5 times. Nobody said that when I started, otherwise I might have complained. But so there was an internal project in ARM to get something that would boot, so we had something for people to test their CPUs with. You know, if your hardware or your simulation will get you to a prompt, then it's probably working about right. But that wasn't allowed to be shipped out by legal, so that was a pain in the arse. And we had to do it all again in Ubuntu. And then Ubuntu got some hardware, and our friend down there did most of the work on the next rebootstrap. And then we had to do it again back in Debian. Sorry? Indeed. So it turns out you need to do this a lot. The net result is that now 96% of Debian architecture-specific packages are built. That's 130 more than it was when I gave this talk a month ago. A number just don't build, and quite a lot are things currently marked as not for us. That's Debian. So this is nominally a distro-independent talk, I should hasten to point out. However, I'm a Debian person, don't know anything about Fedora, so I'm afraid all the examples come from Debian. But really, we're talking about what's done upstream. And secondarily, whether it's actually made it into distributions yet. So please, Fedora people, stick your hands up if anything I say does not apply in Fedora world. Yeah, so a load of stuff not for us means the maintainer said it shouldn't be built on this architecture. Now, there's a whole load of stuff like the PC clock poking hardware, which obviously isn't appropriate for ARM64. But then there's some things which probably just haven't had the architecture added to the list and will in fact work. We haven't really been through that list yet to see how much is left. So, a nice little graph showing that basically ARM64 is now in the pile of architectures at the top that basically work and have most things built. These next two down there are the BSDs, which are sort of working. And I don't know what that is down the bottom. Herd, yes. Herd's got quite a lot better over the last, decade? So you can just see where the little blue spike on the right is where ARM64 was uploaded to Debian official, along with PPC64. So that's the two lines that go right together there. So because we've done all this work before, once you actually upload it all officially, pretty much everything just builds and you go up to the top. So what is done? All these primary languages are done and ported, often for quite a couple of years now, 3 years. Various things are ported but not necessarily optimized. So Free Pascal was a notable exception, but that was uploaded like half an hour before my talk at FOSDEM. And you go, okay, cool, I'll take that off the list. So the most obvious missing things, core stuff now, is mono, i.e. C#, libphobos, which is, so D itself, there is a GDC compiler, but there aren't any libraries, so you can't really do much in practice. And Lua has a C implementation, but not the JIT. So, yeah, so mono is the biggest thing that people might actually want, but isn't ported. So in fact, there is a port, but it's not been released as free software with anybody. And unless someone pays the author, I don't think he's going to. So that's annoying. And yeah, libphobos. So that's, 23 packages in Debian need mono. So apparently nobody cares enough to actually pay for this or do the work again or whatever. There is, of course, now Microsoft have freed up their implementation, Core CLR, so we could all start using that instead, which might be a better long-term plan. I don't know anything about it. Does anyone have any opinions? Apparently not. Fine. Core CLR isn't even packaged yet, so that's not.
I would love to see Linaro actually do one.
Use a microphone.
Does it have no button? No, it's totally on. I would love to see Linaro actually step up and do the mono port. That would be lovely if you could find someone with the time and the expertise.
Yeah, well, so, and it's done, but I think we can't find anyone who's prepared to just give the guy a few £1,000s, and then it will get released. Apparently nobody cares, because it only does tracker and, I don't know, some other things. So somebody, the problem is Linaro doesn't pay for anything, right? Members have to care. So we need a member that cares about something written in mono enough to pay for it.
So what major package is written in mono? Well,
yeah. Well, so all the things that people used to use and were important parts of the GNOME desktop have been replaced by things that aren't written in C#. So nothing critical. So the games people care, but they're apparently paying for private licenses. So, yeah, so if anybody would like mono, it's kind of available, but it's not going to be publicly available without some cash or some work. Node.js, yeah, so that got fixed. So these are all the things that have been fixed, varying degrees of recently, and they were issues. libv8 is the JavaScript implementation used by Chrome and MongoDB and a few other things, Node.js notably. It doesn't have any API versioning because web people, so it's all a bit of a pain in the arse for distro world where we actually kind of need stuff that works together. However, so most big things like Chrome all have their own internal copy, which is synchronized. But anyway, so it was ported to ARM64 quite a long time ago, but the versions everybody was using were older ones, and it's taken a while for people to release newer things, like the new version of Debian that uses a version of libv8 with ARM64 support, but that is all in distro world now. So that's largely fixed. Golang is now, so version 1.5, I think, is now in distros. Like I say, Lua we have, but no JIT. Camel, again, was done a while ago and has now percolated into the distros last year. SBCL is a fast Lisp implementation, which is mostly important because RobotOz uses it. And it turns out you can write all your RobotOz packages in Python, Lisp, or C. I don't know if anybody actually writes them in Lisp, but they can. So yeah, Perl 6, Julia, and FPC just got done last month. So yeah, optimizing things. So there's a fair amount of software that has a C version, but that's kind of slow, and there's optimized stuff using assembler or neon or intrinsics or whatever. Now, as Mad Dog over here knows, we had a look through the list about, Steve McIntyre went through a couple of years ago, and how many bits of software have a piece of assembler in them? Yeah, and it was like 1,000 or something. Sorry? 1,400, Mad Dog tells us. Now, quite a lot of those don't need assembler. That was the easiest way to make things work 20 years ago on multiple architectures. So, for example, AlsaLib, Riku did a fine patch deleting 10,000 lines of assembler implementation for 15 different architectures and replacing it with a very short bit of sensible C that did the same thing. There's probably quite a lot of that could be done. So, performance.linaro.org, is that still the right URL, John? Is a place where basically we've set up a project for people to go and look at all these things and port them or optimize them or throw away the pointless assembler, whatever is required. How are we doing on that? Do you have a mic?
So there was a certain amount of success with it, that various people looked at it, and there was even cases where university professors used it in their classes to have their students take a look at it, and they did some work. The biggest problem we found was that some of the things you mentioned, that either the packages that were listed had no real use on ARM because they were oriented towards Intel,
Right.
or somebody had already ported it as part of a package or something like that, so the people, when they started to look at it, found out that the package they went into is already ported and working. We're looking at it more or less that the porting work is done, and now what we'd like to do is keep on with the performance side of it. Mm-hmm. But where we need some help with that is what types of performance do you really want for each package? Because performance can be measured in speed of execution, performance can be measured in efficiency of the code, performance can be measured in how much memory does it use. That's what we need to take a look at, because it's no good to optimize something for amount of memory when it's going to really suffer with speed or efficiency.
Okay. Thank you. So what else? So optimized things, yeah, we said GCC, LLVM. I understand the compiler's done, but there's still work needed on the linker. If we have any LVM people here. Java 8 and 9 are in a good state. A lot of work's gone into those. OpenSSL is now using the crypto instructions. If they're available, just dynamically, it works. libv8, as I said, is done. The FFT library has Neon support, so that works. 32-bit and 64-bit. GNU MP is done ages ago because we need that for the compiler. So Hadoop and Ceph and the kernel all have CRC and crypto support enabled, again, if the hardware capability is present. Zen's been, it turns out the Zen people mostly got to delete reams of code for supporting obscure shit in x86. It was much simpler in ARM world, so they were pleased with that. Things that are left, yeah, so the Mozilla JIT's not done. I think that's a big and useful piece of work. Is anybody sufficiently enthused, known to be working on that? No? Okay. Golang is already being worked on. So OpenCV is the thing for accessing GPUs, which I think will be useful. People probably want to do that, but I'm not aware of anybody working on it. Any hands up? Somebody?
Just one comment. You said that Hadoop is done. Actually, the native libraries are still missing.
Okay, so
When you try to run Hadoop on ARM, it says that you cannot find native libraries. And in Intel, you have 8 native libraries.
okay, and that's
So
on
it's
what?
not complete.
On what OS? So on Fedora or Debian or Ubuntu or?
Well, actually, I tried
What do you mean on Linaro doesn't provide Hadoop?
the
does
file
it?
system. I just took the file system for
Okay, well,
Well, and I tried to run Hadoop, and I download Hadoop from Hadoop. I mean,
right, so just
so
using the
there is-
upstream thing and
There is
building
a
it.
need for native libraries. If
Okay.
you want to run faster, you need native libraries.
Fair enough.
So
Ricky?
native libraries are missing for ARM. That's
Okay.
it.
I think that native libraries are available, but the Hadoop installer script from Hadoop website does not understand how to get them.
Okay. So I think if you use the distro version, you might find it work better, I think is the bottom line here. But okay, sounds like something we should look at. Right. Cool. Oh, is anyone taking notes? There's a Etherpad thing linked from the thingy page, so if somebody could please write down these, because I'll forget. There's a job for you, Adam. Write down Hadoop on the Etherpad. Thank you. Linked from the page for this. So OpenOffice is built, but the Uno bridge thing is not done. Again, somebody needs to care enough to either do it or pay a small number of thousands of pounds, dollars to get it done. We have someone who's happy to do that work, but he'd quite like to be paid for it. It's not entirely trivial. FFmpeg, again, a lot of the obvious stuff has Neon support, but again, I think there's a fair, less popular codecs and things that aren't done. Anybody care about that? Not here. So is anybody actually using FFmpeg and find that basically it works so far as they're concerned and the things they use are optimized already? They were a very quiet lot. Luigi, we mentioned, I don't know if R and Atlas need optimization, so Eric mentioned Atlas in his talk, and I know if you don't tell it about an architecture, it spends literally days working out what the fastest way of running itself is. We wondered what the hell was going on the first time we built it, because it's like still building after 3 days, and you go, what?
On the Luajet, last month I managed to get a high key to the development team at the University of Catholic University of Rio de Janeiro.
Okay.
So I will hit on them a little bit
I
too.
did just have a look actually before this talk, and like 2 years ago, someone said, if someone gives me some hardware, I'll do this. So
They've got
we
the
should
hard-
probably have
they-
noticed that a little bit sooner. But
They've got the hardware now.
right, okay, brilliant, well done. Thank you. In Linaro? Okay. Toolchain group in Linaro is also having a look at this. So it looks like the Luajit thing will get done soon. Is there anything else people are aware of that needs optimization, porting, that they've...
I'm sure Git could do it somehow.
Git?
I mean, for some reason, it feels for some reason, Git feels quite slow on an ARM64 machine. There's no reason why it should be that slow.
It's all just C, right? Doesn't use anything particularly fancy.
It benefits a lot if you have an optimized SHA-1 function. I think it's
Okay.
SHA-1 that it uses, right? SHA-1 is in the CPU. It's in the CPU. Yes, but it just needs to use it.
Okay, right, so we think there's some specific instructions that we could be using for... Okay, does anybody want to take that on or aware of... Should we just put it on Linaro's list, basically? That would be a really useful thing, especially because we all actually use that, so... Sorry? Someone say something? Oh, right at the back. There you are, Chen. So I can't hear you, so I don't suppose everyone else could.
Sorry, I was mentioning Chrome browser.
Right.
So I came in, maybe it was already on a list, I don't know, but...
So Chrome uses the libv8 JavaScript engine, which is optimized. So
Right.
we believe that's done. So if it's going embarrassingly slowly still, then somebody needs to do some more work. But we expect it should be broadly equivalent. Sorry, someone said hardware video decoding. Right. What you mean, we're not using that basically on some GPUs. Get a mic.
I don't think Chrome's plumbed for hardware video decoding on ARM.
Okay, so you mean you've got a video in a page sort of thing that's staggering about. Okay, add that to the list, Adam. Oh, well, okay. Use a good old-fashioned text editor, they're great. Oh, I'd like to point out, I'm presenting on Windows here because this is the day VGA became too old. There was no VGA on this lectern, so I couldn't plug my laptop in. How quaint. Yeah, I guess it had to happen one day. So this is just a list of stuff that's actually blocking things. If you look on the Debian's build thing today, so Mono and libphobos are up there. OpenAIS is some ancient library nobody cares about anymore because it hasn't loaded for years, but apparently some things depend on it. POCL is some GPU CL library thing. Apparently it doesn't work. Diet libc is yet another libc, which apparently nobody cares about. Anyone care about Diet libc? It's not been ported to ARM yet. No? Dead. So FFF call is the same thing as FFI, you know what I mean, the function call interface thing, which some things use. I don't think that's actually very hard to fix. But yeah, clearly nobody cares that much about that, and a few other things. I'm not sure what's wrong with kexec tools. Anyone know why it doesn't work?
Well, it doesn't work because there's still no support for the kernel. Yeah.
Okay.
So we have patches that just can never run.
Okay, so kexec needs... So the discussion here is that there were some kexec patches, but they've never made it in, so we should probably fix that.
We will be.
Okay, that's on somebody's list.
Yes, all of the kernel work groups like
Cool. So other stuff, so there's things which are just not relevant, like NVIDIA support, and NVRAM tools, and PowerPC utils, and other stuff that's just for other hardware. But then there's things which might be relevant. OpenAFS, the Andrew file system, that's kind of vintage software. I'm not sure how much people care about it.
Yep, people care about it.
Okay, right. So that needs fixing, doesn't build. QtEmu, I think it's some wrap around QEmu to make it pretty. Various bits of it. Like I said, there's like 300 packages in the list. Please look at the list, and if there's anything in there you care about, fix it. Often it's trivial. Sometimes it is literally as simple as adding ARM64 to the list of architectures it builds for. Or updating the auto-foo. What joy. So I'm working my way slowly through those when I get bored, but it's going to take a while if it's just me. So often the complaint, of course, is I haven't got any hardware. That's probably less of a problem here than some other places I've talked, but there are a few online things. So Run Above have the OVH thing. You can get an ARM box to use remotely. You can use SUSE's open build system. They have ARM64 boxes, which is quite handy. Linaro have the build farm. I'm not exactly sure what the procedure is, but basically, if you need access to the build farm, ask, and you can get time on a machine. Debian have port... Really? Okay, cool. Ubuntu PPAs have ARM64 machines, so that's easy. Debian porter boxes are great for Debian developers, but a fat lot used for nearly everybody else. There is, in fact, one Debian porter box which anybody can get access to if they ask me nicely. So if you can't get a box any other way, please ask. There is actually hardware available these days, and increasingly it doesn't cost an absolute fortune. So it's pretty much in order of cost, not quite. But so yeah, I think most of you are probably aware of this, but there's the APM boards, which are pretty good and available, and you can use those. And Juno, which works, is a bit slow. Moonshot, which is jolly expensive and very nice. If you've got one. The soft iron things, I think, has anyone used these? Are they good? The man there?
It's another drive, but it's basically the AMD weapons board.
Yes.
It's really, really nice.
Mhm.
That's my workhorse.
Right. So yeah, this soft irons machine is quite nice and not outrageously expensive if you want a proper server kit.
One caveat though, this really, really nice 1U chassis blocks the PCI ports because there's no 90-degree adapter. So you can't,
you can't.
if you keep the board in that stupid box, you can't use the PCI.
Okay, right.
Buy
So,
it with a normal ATX case and all of a sudden it becomes a useful machine.
right. Okay. So yeah, you can't get your PCI cards in the super slimline box. So there's this gigabyte thing, which apparently had the kernel was a bit of a pain to start with, but I think that's getting fixed as well. So that's XGene based. And then of course there's 96 boards. This one even has free graphics. Whoa, how cool is that? And as of yesterday, we had this cello thing, which is probably rather nice actually, because I get like Ethernet and a useful amount of RAM and all those good things without having to pay a fortune. Do we know what the date for these is? Okay. Right. Yeah, well, let's hope it appears a bit faster than the Husky has, but we'll see. And then, of course, there's super cheap things appearing, well, at least being threatening to appear. So you can have a Pi 3, but I just discovered while I've been on holiday, but it's actually only in 32-bit mode until somebody does something, and it is Broadcom. That's true. Yeah. Okay. So that's kind of useful, maybe. Sorry? Odroid C2, which should be out soon? I don't know. Is this it? And, okay, so Odroid C2s are probably on the cusp of actually, you should be able to get one. Is that an all-winner based?
No, it's
Amlogic, okay. So, and I guess they're cheapish?
Yeah,
$40. So that's a nice board. And mainline support? No.
So none as of 4.5, 4.6 only if I get it this week. Getting
Okay, so that might have 4.6 support. So this thing's very cheap, but again, there's a problem with freeness of software for actually running things and kernel support, and it might be a few months before you can get one. But anyway, so the hardware situation is basically improving, probably quite fast now. I expect all sorts of things will appear and become available, and we can all stop moaning about not having any hardware. And anyone out there who said, oh yeah, I'd fix it if I had some hardware, we can now just deal with that. So the interesting question is about like stuff not working. Sometimes it's really obvious. So botch is a rather obscure bit of software unless you care about Debian dependencies. It calculates them all, but it's written in OCaml because Frenchmen. And to be fair, for that sort of thing, that is actually quite a good language. It's just, most of us go, whoa, scary. And yeah, it was 37 minutes to build on Intel 64-bit and 5 hours on ARM64 because there was only the C generic implementation of OCaml until we got a faster one, and it gets 4 or 5 times faster, which is great. I don't know how much more software there is like that. I mean, that was basically a language thing, but it's a useful benchmark of how fast does my language actually work. Like I say, if anybody knows of things which they've noticed are suspiciously slow, and we've had a couple of examples, I'm keen to know so that we can put them on somebody's list. Otherwise, it won't get fixed. It's quite hard to benchmark across architectures. The Debian build these are kind of useful because you can compare relative measures. These are these speeds on these architectures and these speeds on these architectures, and you can see how they change over time. But it's not a very accurate system. And nobody, I think, is really doing benchmarking. Is anybody looking at our optimizations to see what's working fast or slowly? I mean, the compiler people look carefully at some low-level stuff, but in terms of that, there's a man here saying, I think it's a bit slow.
The enterprise group are doing a bunch of that sort of stuff for their applications.
Okay, yes. So Mr. Kappa has done, hence the Hadoop optimizations. So that was Enterprise Group are doing some useful work in this. Yeah. Anything else?
So when you're finding issues in the context of Debian, are the optimization tweaks being rolled into things like open embedded?
Well, so in general, everything like that should be done upstream, right? And we are. I'm not aware of people just sticking, anything, the only stuff that only stays in Debian is packaging type issues, or, kind of auto-conf fixes don't necessarily go upstream, because upstreams are a bit, sometimes don't really understand and go, no, we want to ship our version from 8 years ago because that one works, and we want to leave it alone. But yeah, anything that's actual, neon optimizations or whatever, that's all upstreamed. So.
Yeah, for code patches, I guess I was thinking more like just building flag tweaks and things like that.
Yeah, obviously in distro world, you don't, there's a specific ISO and build flavor set. So we do everything the same, or at least we should do. Sometimes upstream tries to ram some extra options in for particular hardware, and we take those out again. But yeah, I guess sometimes we are fixing things which are basically just wrong upstream, and so far as I know, people are doing a pretty good job of doing that work upstream rather than just in distros. Please, if anyone wanted to look through all the patches, you might find things which really should be upstreamed and haven't been. It's not a trivial matter to find them all. So I believe we're doing a reasonable job, but obviously I haven't looked at everything in the world to check. Anything else over there? Hold it a moment. Can't hear you.
And in your PPT, you showed that you have optimized the OpenSSL and Hadoop and Ceph. Can you give some detailed information about these three software?
Some information. Sorry.
Hadoop.
Yeah.
Okay, and Ceph, you mentioned that you have optimized the CSA, and but how can I find the final results or
of how much difference it made?
The difference and the report about it.
I would ask the LEG group. I think they did some actual benchmarking on that. So if you can find Steve Kappa, he will know. So I don't have any benchmark numbers to hand. I just know that work was done on that, and it's implemented upstream and built. But if you want to find out how much difference it made, you'll go and talk to the network enterprise group, and they can probably find you some numbers.
So OpenSSL, and you have optimized it, and it's your patch have committed to the mainstream.
Yeah, so the SSL thing's upstream and has been for a while to use the crypto hardware if available.
Is there any compare before and after report about this?
I'm sure there is somewhere, but I don't have that data.
Okay, thank you.
All happy? Everything's as optimized as we need? Okay, marvelous. Thank you very much. In general, we are keen to know of anything you notice that needs work. Please tell me or tell some appropriate working group if that seems more sensible. Thank you very much.